RSVPs. Some folks should pile in, and plus we'll have the recording after. So with that, all right, we'll go ahead and kick it off. So thanks everybody for joining. My name is Jason Hughes. I'm here covering for Alex Merced, the organizer of this group, who's doing me a favor right now. So I'm helping him out here. But going forward, he'll be the one organizing and kind of running these things. So today we have Santona Tuli, who's a principal product manager here at Upsolver, who's going to present the past, present, and future of data workflow management. So with that, Santona, I'll pass it off to you, and probably feel free. Do you want, Santona, would you rather do chat or like come off mute, ask questions, or more Q&A in the chat?
Yeah, I mean, I think we can do just come off mute and ask questions.
Okay, cool. Sounds good. Well, then I'll pass it off to you.
Awesome. Thank you so much, Jason. Yeah, it's a small enough group. I think we can keep this very casual. I'll share slides and sort of talk through them, but please feel free to interrupt at any time. And I mean, we could also do a quick round of intros with the folks that are here, if that works. Is that good? Cool. All right. As you heard, I'm at Upsolver doing product work, and I've done data work in the past. And I'll just randomly call someone because Zoom order is weird. Whaley, am I saying that right?
Yeah, perfect. Thank you so much. I'm currently a project manager at a nonprofit handling technology partnerships. I was previously a software engineering apprentice at Asana on the data infrastructure and engineering team. Currently just joined with Zach Wilson's data engineering bootcamp. So I just like data management.
Very cool. Why don't you pick the next person to go?
I was going to ask. I'll pick Ralph, who's on camera.
Yes, I'm Ralph Quick. I am AWS Cloud Engineer and working my way up to Solution Architect Pro, and wanted to get acclimated more with databases because that is a big component to being a solution architect.
Do you want to pick the next person, Ralph?
Yeah, go for Kenneth.
We're doing intros, but if folks don't want to speak up, that's also totally fine. Maybe I'll just ask, does anyone else want to introduce themselves? Please come off mute if you do.
Hey, Santona.
Hi.
Let me see if I can get my camera on here. My name's Nick Miranda. I work in financial digital transformation at an electric company. What I'm really interested in this meeting is, you know, I'm kind of a citizen data manager, and we create kind of custom ETL jobs. But what we find is that what we're creating is just not sustainable. They don't have staying power. So really trying to understand best practices to build longer lasting data flows is what I'm particularly interested in.
Very cool. Yep. All right, hearing no one else pipe up, I think I'll get started with the presentation, but please feel free to interrupt. So let me share my screen. And I'm going to go into slideshow mode. Yeah, just give a holler if something's not working. Cool. All right. So yeah, I'll talk about data workflow management. It's going to be fairly high level, and we're going to talk about trends in data workflow management, what I've seen, you know, sort of how I've seen it evolve over the past 5-ish years. And that's a picture of my puppy. Her name's Ridge, and she cares a lot about data workflow management because that's what I care about. Okay. So a little bit about myself. I have previously worked in machine learning and some data ops work. I worked as a machine learning engineer in the NLP domain. then I started switching into more data tooling and thinking like a product manager. Finally made the switch a few months ago to Upsolver officially as a product manager, but staying in data tooling, specifically data workflow tooling. So that's me in a nutshell. And what we'll talk about today is as I've shifted more into product type work and in the tooling space, I've had the privilege of talking to a lot of folks and, sort of learning what they're doing as individual developers and also as teams, like what their goals are and their pain points, etc. So we'll talk a little bit about my findings. We'll talk about data products, which are kind of hot right now, and data freshness, why I think that's important. Then we'll talk about the themes in tooling, and I sort of separated into first, second, and third generation tooling, but that's just Santona speak. It's not official. And we'll look at some example workflows in sort of batch and streaming contexts. Okay, so a few learnings at the team level. Most use cases for data teams are still around analytics, which is to say we get data from some application or whatever other source. We are understanding the data, doing some analyses on it, getting insights. And that's what we're providing as data teams to our users. However, we are seeing an increase in more data applications. So again, data as a product, machine learning as a product, even analytics more productized, and like getting into the space of real-time apps that we interact with, right, as individuals. I'm also noticing that batch intervals are shortening for various reasons. We're seeing whatever workflows we have that are happening on a schedule, right, in batches, the interval for those are shortening. We're seeing need for a quicker time to delivery. People are more, anxious to get their analytics, just like we like to swipe and then scroll. It's kind of, I think, a similar effect. Cloud computing makes it easy to scale up. So like in one sense, just shortening intervals is cheaper and easier, so why not? But it can get expensive if all of that isn't managed well. So we run into the trade-off, or teams run into trade-offs around, well, what do we need in terms of how fast or how fresh do we need our data? How fast do we want things running versus what do we want? And then we're seeing three types of workflows, right? The more common, of course, are batch ones that are orchestrated on a schedule. Then there are sort of streaming only workflows where, we get event streams, we process them in some way and sort of pass them along. And then there are workflows that sort of unify batch and stream, and those are emerging more and more. Use cases for both batch and streaming are emerging. So the last few things, sort of the fact that batch intervals are shortening and we're seeing an emergence of streaming workflows is an indication that data freshness is becoming more top of mind. Okay, I'll talk next about sort of some individual level learnings, but I can take a beat here if anyone wants to make any comments. So at the individual level, basically we see producers and consumers, right? Or that's sort of the words that we're starting to use around in this space. So as a producer, let's say a data engineer or a data scientist, I want to keep using the tools that I'm familiar with. So if I'm using tool XYZ, if your new tool doesn't integrate with my stack, then I'm probably not going to use it, right? It's a big ask for someone to sort of switch up completely. I also don't want to fundamentally shift my perspective. So this is a really interesting one to me, because if I'm used to doing batch workloads, streaming just kind of seems like a whole different world, and I don't necessarily have to change my whole worldview to incorporate streams. I think there's a little bit of I just don't know it effect going on. And then across the board, no matter what kind of workflow you're dealing with, dependency management is hard. So we should acknowledge that there's a challenge there. There are like lots of different ways in which things can break, the more dependencies you have. You know, in an ideal world, I think we wouldn't have to think about explicitly specifying our dependencies, but it is what it is. I'm not actually sure why I put data quality checks under this bullet point, but of course, data quality is also becoming more something that's top of mind for data professionals. As a consumer, so this is still sort of, you know, and again, like folks who are in the data space are data professionals, but perhaps usually work with data that's been prepared or analytics that's been prepared to some extent. So they're not going all the way back to the source, right? So in this case, I want to keep interacting with my data the way that I'm used to. If I'm used to receiving like tabular data in a database, for example, I don't want to suddenly have to change that like table perspective to like a row or stream perspective, right? Sort of similar to what I was saying earlier. I want to be able to run my SQL queries because that's how I interact with data, and so on and so forth. And we're also seeing an increasing appetite for doing self-serve because people are, you know, just more data literate, you know, how to work with data, what works, what doesn't work, statistical, you know, pitfalls and so on and so forth. So I think that we should, and, you know, personally, I think we should absolutely go towards a more self-serve paradigm. So like two themes that emerge is that the user experience, even for data professionals, right? The user experience matters within tools. And the use case matters as well. Like what I'm building for and what I'm trying to do with my data is largely going to determine the frameworks that I use and the tools that I use. So this is all like trying to make sense of like a bunch of, you know, user interviews and conversations. So it's a little bit, you know, covering quite a lot of ground here, but there are themes that we can try start seeing emerge. Okay, so I mentioned data freshness a couple of times. So let's take a little tangent to talk about data freshness and why it's important, right? So data products, how do we define data products? So I personally define data products as so they can be data as a product, they can be analytics products, they can be machine learning products, and even in the machine learning space, right? You can have an ML model that's providing analytics as a product, or you can have an ML application. So there's a wide range of things that fall under data products, but the underlying thing that's in common is that they utilize data. So why is data freshness important for, you know, data or data as a product? If you have out-of-date data, you're going to make bad business decisions, right? For out-of-date, in the case of out-of-date analytics, you have a delayed understanding of your business performance, and you know it might the more time that passes between when the data was generated and when you're making when you're using it to understand something about your business, the more like you're going to be out of touch with how your business is actually running. Out-of-date predictions, this is I think the thing that we can relate to as individuals the most, because when you have a ML model that's giving you out-of-date predictions, like you just bought a backpack and then it keeps showing you 500 more backpacks, well, that's an annoying experience, right? So so I think we can more or less agree that near or data products with fresh data is what we're going for, right? So I'm going to call that near real-time data products. And we definitely have batch processes that are feeding into such data products. There are some challenges with batch workflows. Typically, the data is fresh up to not typically, necessarily, definitionally, the data is only going to be fresh up to the batch interval. When a pipeline failure or when a run failure happens, that tends to compound. So the next time, unless someone steps in and does, you know, some like refilling or backfilling or rerunning, then the failure tends to compound. And backfills, again, are manual, like usually, unless you're write super robust pipelines, and even then I'd be a little bit skeptical. Usually people, you know, engineers will have to go in and do backfills themselves. So what do we do to get to more fresh data and more near real time? We, as I said before, we tend to shorten the batch intervals to just make things go faster. But you run into the fundamental limit of, well, how fast is too fast, or how fast can you actually run? If your data is let's say that your data is generated at a certain cadence, there's a fundamental limit there that you can't, process it any faster than it's generated, and so on and so forth. So it's like A has to happen before B can happen, and that's hard to put on a schedule. And then even if you speed it up, that addresses some issues, but run failures are still a big deal. Those are sort of the main ones. Similarly with stream processes, we have our own set of challenges there. The the challenges. So streams have their own cadence, right? The data will arrive when they do. You can't put it on a schedule. So it's hard to put guarantees around the product and what I'm going to deliver you, right? So it's going to be fundamentally dependent on how the data is coming in. If I want to fix issues in a stream process, in a stream workflow, then I have to stop something that's naturally a continuous process. So there's an artificial thing happening there. And then transformations on streams is doing transformations as the data is streaming is hard, not impossible. Certainly we're doing it, but it's harder and expensive than in batch processes typically. So what we end up doing though is try to do more and more transformations as the data is streaming. But there's this really cool challenge of, well, okay, what happens when I have multiple streaming sources, right? Okay, I can do transformations on a stream that's coming in, but all of a sudden I have 5 different streams and they have their own cadence, and I want to do some sort of joins and aggregations on them, and that's what's going to feed into my data product. So that's a tough challenge. What that relates to more fundamentally, I keep saying fundamentally, is that dependencies are hard to are unnatural in streams, because streams are their own things. So they don't naturally allow you to do arbitrary combinations and dependencies. And then this is very obvious, but I wanted to say it anyway. You can't the challenges of the two don't cancel each other out, right? You can't just try to put the two together and make things all better. And putting the two together is actually what's really hard. So going back to what I was saying earlier about experiences, the user experience of data engineers being used to a tool stack, not wanting to change your perspective or integrate with an arbitrarily large number of tools. Just combining these two different technologies is what I think is a big challenge today. And that's because the underlying infrastructures are so different. You don't think stream and think Airflow, and you don't think batch and think Kafka, right? Okay, so here's my 3-generation breakdown of workflow management tools. So I think we started with how do we schedule our workflows and how do we set the dependencies, and we started building these orchestrators in such a way that whatever your language was of choice, then you had some choice, some option to work in that language. So going back, there's cron, and then we built Airflow, and so on and so forth. So there is this not a lot of, I mean, there's maybe perhaps another way of saying, actually this is a better way of saying it. If you want to orchestrate using Airflow, your batch processes, you're going to need to do that in Python, and you're going to have to bring that into your other, whatever languages the rest of your workflow is in. I think in the second generation, what we've started to do is we've added robustness and additional flow controls, for example in Airflow. There's the branch operator and things, so you can do more complex things. It's not just scheduling. and A goes to B, it's more, okay, if this happens, you can do this. If this other thing happens, you can do this. So we started building more complex workflows, DAGs. We also started making them easier to author through various abstractions, right? Again, going back to the Airflow example, there's a task flow API, right, where you can just say, well, this Python function is a task, and then sort of just it'll understand what that means rather than you doing the typical Airflow language. And I mean, for better or for worse, I mean, I love Python, but for better or for worse, we moved deeper into Pythonic ways of writing our workflows, and sort of thinking of the actual orchestration like as a wrapping layer on top of our Pythonic code. I think the third generation, which we're there, but also kind of headed there, is a data first / data triggered way of authoring workflows. And I'll go more in detail in the next slide on this as well, where dependencies are more inferred rather than explicitly stated. So you can declaratively say, okay, this is the format that I want my data to get in. These are my sources, and like how you get there is sort of left up to you, to the orchestrator, to the service that's doing it. We're definitely incorporating more observability into our workflow orchestrators, because it's becoming evident that this is the layer, this is the thing that sort of ties a lot of our stack together and a lot of our what's actually happening in our software. And we're moving. We're, I think, being more open to different languages. So this is opposite of I think what Frisian was, which I will admit I was explaining it wrong in the beginning. But I think we're more like, if you want to orchestrate in SQL, you can do that. If you want to orchestrate in PySpark, you can do that. So we're moving there. Yeah, so this is where I think we are. Today we're sort of straddling the second and third generation. I mean, this space is moving so fast. It's really hard to say, but I think there's still a lot of programmatic workflow authoring software that are like, doing some really cool stuff with abstractions. And then there is more declarative workflow authoring on the market today as well. Okay, so in a more concise manner, this is how I would explain it. First generation workflow authoring tools, you write what you want for it to happen, and you also specify how that's going to happen explicitly. In the second generation, you write what you want for it to happen, and then the how is sort of, it's like a wrapper on top of the what, right? So you can have the separation of this is my actual workflow, and this is how it's going to be orchestrated or run. And then in the third generation, you don't even have to worry about that wrapper layer, right? You write what you want for it to happen, and the how is going to be inferred. Again, this is, I think, where we are today in between the two. Okay, so I'll talk about a few different orchestrators briefly and where they are each today. So with Airflow, we're going towards a more data-based triggering as well. It's not complete, it's not there, but the idea of triggering one DAG based on a data set that was that arrived somewhere or that was created by another DAG is coming to be, and there's tons and tons of community work on Airflow. So there is constantly more integrations are being built. So it is certainly easier to integrate with. There is a question or something in chat. DAG. Oh, sorry. A DAG is a directed acyclic graph, which is sort of how workflows are orchestrated. I'm just going to write that real quick. Basically, it tells you two things. It tells you that there is a direction in which the workflow is going to progress. So A happens before B, right? And that's always, and that is related to acyclic as well. It's after you do B, you can't go back and do A again. So you can't have these things that depend on each other. And then the graph is just how it's typically represented. So if you're starting to look into workflow orchestration, workflow management, then yeah, I'd recommend getting to know DAGs. They're there. Yeah, love, sometimes less love, but yes. No, I like DAGs too. I mean, there's no way to get away from DAGs, but there are abstractions that make it easier. And there are some like scary looking DAGs out there, which is just, I think it's really bad for us, right? Like, because it gives us idea that DAGs are necessarily these complex and like huge things. But there are definitely ways in which you can split up your DAGs and make them both more readable and understandable and just like more logically separated. So, and if you want to chat about any of that later, by all means, I think I'm approachable. Just find me on LinkedIn. All right. Then there's Prefect, which uses primarily like sort of Python decorators in order to specify the workflow. So again, this is this layer of this is what I want. The data transformations is kind of separated from how the actual orchestration happens. So it's cool. It's a layer of degree of abstraction that I'm very fond of. There's this open source library called Hamilton, and a couple of friends of mine are building a company on top of it. It's called DagWorks, which is also really cool. It takes this decorator, Python decorator idea for workflow pieces to further so that into a Pythonic framework completely. So all you do is write Python functions, and it's heavily typed. So you just say, oh, these are the input columns, these are the output columns, and that's all you do to specify your orchestration. It's quite cool. Then there's the set of tools like DBT, where taking the other approach, right, making the tool more usable and opening it up to wider audiences. You can write your very and in your workflows to some extent in SQL. So you don't have to know Python. You don't have to do this complex, very specific way of writing DAGs as you do in Airflow. You can just sort of think of the data and what you want for it to happen to the data. There is Databricks, which does a couple of cool things. So Databricks has jobs, which is very similar to pipelines in Airflow. And the cool thing about Databricks is that you can write your worksheets, your jobs in the language, in your language of choice. I mean, that's not an infinite number of choices, but the last I checked, they supported there's definitely Python, there's SQL, I think Julia supported PySpark, etc. Don't quote me on Julia, I'm not actually sure, but they're definitely increasing language support, which is, again, nice. It's nice to be able to incorporate, you don't want to have to pass off, okay, this is, what I want for my data to happen, and then you hand that off to someone just to, orchestrate that. You don't want to have to do that. So certainly being able to do it in your own preferred language is great. Databricks also has this thing called Delta Live Tables, which combines batch and stream. And that's the other way I think we are shifting in workflow orchestration. So as I motivated earlier, I think we're seeing more stream applications where in addition to batch, and we're going to want to incorporate both into our workflows. So Delta Live Tables are pretty cool. They let you do that. And the fundamental idea there is it's data triggered, data driven pipelines, and not on a schedule. There's Mage, which is a new kid on the block, which also lets you do batch and streaming. And last I checked, it was Python and PySpark. So not quite SQL, but at least it's more than one. Well, I mean, you could argue PySpark is not its own thing, but it's extensible at least. And then there are tools like Upsolver, which is where I work, where we also combine both batch and stream in the same tool, same pipeline. And the other cool thing we do is we do everything is in SQL. So the way you write your workflows is just by writing SQL transformations. And depending on how your data or when your data arrives, we'll just run the pipeline for you. So that's pretty cool as well. So I'm going to look at a few different workflows and how they're how I've orchestrated them. So these are all roughly from my experience. So in my NLP based role, we built a predictive routing engine, which is it was an ML application, as I said, and there were two components to it. There was an offline training and component where we trained the model and then deployed it. As your typical data science ML workflow, you load in the data, featureize it, and you want to use the latest data for this. I'll pause for one second, for a little bit. Are there any questions? Okay. Okay, I'll give a little bit of context. So this was for a this was for a company in the customer relationship management space. Basically, if you had a question about a product that you were using that if that product was a client of ours, so for example, Airbnb, you have a question about your Airbnb reservation. When you ask it, that question would come through to us directly, and we would figure out where to route your question in order to get it resolved. So it might be to another person who knows the product in and out. It might be just to an article that already exists that we know about, and so on and so forth. So the task was, your question comes in, we have to understand what you're asking and understand like what the right approach is to answer your question. And that's where the ML sat. So the predictive routing engine. So every so often we would retrain that ML model because, again, we didn't want it to get stale. And we would train it on the latest data that was available, of course, again, to stay current and relevant. And then we'd deploy the model. This was the offline component of this. And so this is a batch process, right? This is happening every so often by definition. Then there was the online inference and monitoring component, where each time you would ask the question or the user would ask the question, that's a streaming event. It's coming in, we ingest that event, we featureize that single data record or event in the same way that we would featureize our data offline. Then we'd call that predict endpoint for the model, get that prediction in real time, serve it to the user. And we'd also want to track the data, model, and prediction attributes over time. So this is fundamentally a streaming concept, right? Because it has to happen per record as the record arrives as you ask the question. As is natural, we had sort of two different technologies that we use for these two portions, because that's sort of how it has been done. Even today, this is probably how you'd build this, right? So we did the offline training in Airflow, and we used a message bus, RabbitMQ, for passing messages around in real time. So this is sort of what it looked like. User asks the question, it goes through Rabbit, comes into our microservice that hosts the predictive routing engine, which is the ML model, which every night gets retrained on most relevant data, and not just like from the past 24 hours data, but that would certainly be weighted more heavily, but it would go further back to get more data. And that would happen, feed into the predictive routing model, and then it would get this prediction, which would impact the user's experience in real time. So this goes back to the user that's asking the question. They're getting a response, or they're getting connected to someone that can give them a response. So this is roughly the architecture. Okay, now let's look at a different example, or a workflow example. This is also something I built. So this is an issue triaging service. The offline training component is exactly the same. We load and featurize the data, we retrain the model and deploy it. Batch process. On the on the inference component, instead of being online, this was actually, I did a micro batch. So I'll pause briefly to answer Davina's question, although I won't. I'll give a wishy-washy answer. Which is to say, for the actual ML component, if assuming that's what you're asking, for this particular application, we were using TensorFlow, and then we were doing transfer learning on top of large language models to get specialized learning per network. So you would have a different model for Airbnb and for a different language, and for those were the two, like the network and the language, I think, is what would have different model instances for that. But yeah, I mean, deep neural networks, I don't know if that answers the question. What tools? Yeah, if you want to discuss more of that specific application, I'm happy to do so later on. And by the way, feel free to unmute and ask questions directly instead of putting them in the chat. Cool. So for this specific, for the issue triaging, and I'll talk about what I mean by that in the next few slides. I went with a micro batch inference model instead of an completely online one, because the use case did not demand a fully online real-time application. Instead, I was able to just micro batch and do it ever so often. But the basic idea is the same. You still, you still want to ingest and featureize data records as they appeared, and do the prediction and so on and so forth. But I could do this in batches, because actually I should update this. I didn't necessarily have to use a single, do it on a single data record. Instead, what I was able to do is schedule every so often, pull any new data that's coming in and do the work on that batch of data. And this is definitely much better explained with examples. So this particular issue triaging one, what I mean is I was looking at the open source project Airflow and its GitHub repo, and issues literally meaning whenever someone created an issue against this project, I wanted to know how complex that issue was, basically how long it would take someone on the Airflow team to respond to it and resolve that issue. So, there are tens of thousands of issues on the project today, and roughly 100 new issues, 100 or so, or hundreds of new issues come in per week. So you can imagine that triaging those is kind of important if you have a limited number of people who can address them, to prioritize and also to see, okay, but how long is this feature request actually going to take, or is this worth it and stuff. So this is what I built. So there's a model underneath it, but this is the front end, right? So this is an application that serves you when the issue number, what the issue is titled, what it's called, and then a prediction on how long it's going to take to resolve it. So basically, a simple classification problem is going to be a matter of hours, days, or something longer. It's a long tail thing. So most issues can be resolved fairly quickly. So these were the three buckets that were roughly that I didn't run into an imbalanced class problem. So this is, and this is why I said this is, it wasn't so important for me to do this online, because, the Airflow team, the Airflow engineers aren't going to sit constantly and watch to see what Santona's model is saying this issue complexity is, right? They'll probably check in, a couple of times a day, see what new issues are here, and getting an idea of how long it'll take to address those is great for that, but it doesn't have to happen all the time. Because it's an ML model based application, of course, you want to do some tracking. So there's, usual model performance tracking around it. And of course, you want to interpret the model. So, just a study of what features are actually relevant to issue importance. Yeah, so that's basically this. I kept the DAGs out of it, but, I had a DAG that was running every night to retrain on all the data. And then I had another DAG that ran every two minutes to grab any new issues that are come in and run my prediction. So this was actually, live and dependable on a 5 to 10 minute scale, which is, as good as that it was needed. Okay, now let's move into an even a more in some ways interesting use case, and one that relies more on real-time and batch combining real-time and batch. So we still have the offline training component. So this is an ad impression attribution service. This is what that means. When a company decides to buy a little digital ad space, right, or you're bidding for it, and then against other companies, and then you buy it, then you serve the ad. That's an impression when you serve it to an individual based on their details. And then if they click on it, then that's a successful impression. So that's a click. Now the click is happening in real time, like as the user is interacting with it. Some features of the ad are actually generated in real time. So we're like, you would get served a different ad than your friend, right? Even with the same real estate. But then there's a bunch of batch data as well around, like, my ad campaign, what I actually want to be serving you, details about you that unfortunately companies will have around what you're likely to buy, etc. So this is a very common use case actually, or that for Upsolver's clients. And it combines batch and streaming. So the difference here in the online inference portion is that I'm wanting to join that live event, the click event of the user, or actually even the serving of the ad, with data that I have in a feature store elsewhere that was produced and put there by a batch process. So that's really the part where I want to do a streaming join, or a join on data in motion against other streams plus data that's in a data store. So this really in the online portion is where I'm wanting to combine a batch and a stream process. And this like divide which exists between batch and stream is really annoying when you have to do it all in one step. And that's where Upsolver comes in. Woohoo! So I don't want to, bore you with too much details or pitch too much, but this is just the architecture for such a use case, for such a workflow. So in the ad example, we've got maybe perhaps a database of all the advertisers who were involved in serving ad on my website. So let's say I'm Facebook. These are all the record of the advertisers. I have information on active bids that are refreshed every so often, right? Maybe 15 minutes, maybe 5 minutes. So that's landing in some bucket. This is all very Amazon specific. That's mostly because we're an Amazon partner and we use Amazon as an underlying tool. And then information on the active ad campaigns for each advertiser. And then there's the stream. This is a Kinesis stream coming in for the actual impressions and the clicks that are happening on the impressions. So what we do is we're able to ingest all of that data into Upsolver. It doesn't matter if it's streaming or batch, you're gonna immediately see them live within the Upsolver platform, and you can query them. But what's cooler is then we can join in motion data across the streams and the batch sources. And the way that we do that is by creating materialized views on top of the tables. So this stream is going to be joined directly against the materialized view of ad campaigns, active bids, and advertisers. So here in one step, you just write a SQL statement and say, select advertiser ID from advertisers, bid amount, join on advertiser ID from active bids, join on your ad campaigns, and then finally join on your click impression stream on whatever primary keys you have, and voila, you have done the join, and you're able to attribute a specific click that happened on your website back to who was serving it and how much, for example, how much they paid for that specific real estate for that moment in time, because that's very dynamic. The pricing around ad real estate is very dynamic, and you get that attribution in real time as the click is happening. And for example, this can power a quick side dashboard that shows the campaign success metrics. So a campaign is only successful if someone clicks through an ad impression, right? And you have to measure that versus how much you paid for it, and so on and so forth. So that's the output that you would get, and all of this is happening within Upsolver, which is a data lake platform. So it's underneath it is S3, and you have this data catalog that lets you see everything that's in there. So yeah, these are three different workflows with various combinations of batch and streaming. And I just wanted to show those. And
I have another quick question.
Sure, yeah.
Back on the Upsolver, where you're just kind of showing that
Mhm.
the workflow there. Did you have to, is this like a no code solution that you can implement, or did you have to utilize APIs for your different data sources to kind of build that flow?
Yeah, it's a great question. It's definitely, it's not no code, but it is light on code. And more specifically, it's a fully SQL based tool, and you write things declaratively. So all you would write is, so you would write create connection, but the integrations already exists, right? So you'd say create connection to Kinesis, and you just give your credentials within a SQL statement, which I think is really cool, as opposed to like opening up a connections, wizard and knowing what to put in. You do the SQL statement, that's done. And then everything downhill from or downstream from there is just SQL statements. So create materialized view, select -- whatever, full outer join or sorry, right join or whatever on your materialized views and tables, and that's it. So all you're doing is writing SQL code, and the orchestration is inferred and happens automatically. And I mean, there's no magic to it, right? I mean, there's some really cool tech in it, but what it really is the data arrives, your pipeline runs. So that's the difference between like an Airflow versus this is we're not running on a schedule. When your data lands in the S3 bucket, it'll come up into Upsolver. When your data arrives in your Kafka stream or Kinesis stream, it'll come into Upsolver, and then whatever you want for it to happen to that data will happen.
I have multiple questions, and my first one might be like more of a client problem, but in your example, like if this were something that Facebook like was a client for, right? Is the QuickSight campaign success metrics, that's something that Facebook would see, right? Because these are all, so if an advertiser wanted access to their specific ads metrics, how would they get them? Would they also become clients of Upsolver? Yeah,
absolutely. I mean, this is a very specific example, right?
Okay.
But yes, I mean, perhaps you'd still be able to do your click activation. You probably would join different data sources, so you already know what you've bid and what your ad campaigns are, right? So you wouldn't need this like advertisers database, but you would want to join. Okay, I got a click from this Facebook ad that I served. Okay, this was part of this birthday campaign that I'm running. Everyone gets an ad served on their birthday, whatnot, and this is how much I paid for that. So it would just your business logic would look different, but that's, again, it would live in Upsolver as SQL code. And by the way, the QuickSight is also just an example. This is just
Right.
for a data lake, tool. You can use whatever inputs and whatever outputs. I mean, it's not literally infinite, but we support lots of different sources and outputs.
Yeah, I was just curious because I haven't worked in ads or with like vendors very heavily. And so like this might be like in the weeds and not about like trends. But the data that's in S3, would Facebook have access to that like outside of Upsolver?
That's a really good question. So in this example, Facebook is the client, right? And they're using Upsolver. So we offer different ways of deploying Upsolver. So we'll host it for you, I think, if you want. But you can also set up your own VPC or data plane, however you want to call it. But so if the concern is at least partly about security and like isolation, that's like not a problem. It's your data, it's going to live in your infrastructure. The other cool thing that I think is cool is, so it's your S3 bucket, right, that Upsolver is using as its data lake. You can actually go in there and look at your data like directly. You can look at the S3 files, you can do whatever you want to them. Like, I wouldn't recommend just randomly going into that S3 bucket and deleting, a data set. That's going to break your pipelines. But this is, we're not, it's not a super restrictive tool. We really think that, whatever the user wants to do within reason should be able to do. So it's very open in that way.
Thanks
And
so
we
much.
would not have a copy of of that data. It's
Okay.
definitely living in your VPC. You're just deploying our tool in there.
Okay. Even if Upsolver was hosting it.
So if Upsolver is hosting it, we would certainly it would like definitely be separate from other clients. And I think this is something that you'd want to get in with like more in detail with a solutions architect if you're interested. But I mean, it wouldn't, the natural thing would be, even if it technically lives in our VPC, we wouldn't like be able to actually enter it. But that's, I mean, that's not a very common, people usually bring their own clouds.
Thanks.
Mm-hmm. Absolutely. So yeah, I'll just finish up with my last slide here and then we can chat more. I talked about a few different things sort of put into one presentation. But my main takeaways are user research is really fun. Especially as a data scientist coming from data, just being able to talk to different teams and figure out what folks are doing and what their needs are, pain points and stuff is a lot of fun. I encourage all data professionals to like sometimes think like product person. The data tooling landscape is super interesting. I mean, there's lots of chatter about it right now too, bundling, unbundling, etc. But it is, I mean, there's perhaps too many tools out there, but there's some really cool tools out there. I think as far as workflow management is concerned, where we're headed is easier to author for sure. I think the days of it being difficult to write a DAG or write orchestration for your pipelines are gone. And I also think that we're moving to a more declarative paradigm because no one really wants to specify the dependencies. If I tell you that I'm going to infer your dependencies for you, I think that's a very tempting proposition. And even when you are specifying dependencies, there are some really cool abstractions that like make it really easy to just say, oh, this and this are related in this way, and you don't have to like have to write 10 lines of code just to specify that. However, even with all the tools out there, I think that the challenge is finding the right level of abstraction for you, right? So different people have different levels of, let's say, like coding ability, different languages that they're comfortable with, different, just a willingness to spend time on, writing a pipeline is sometimes not something everyone's interested in. So finding the perfect level of abstraction is, I think, worthwhile because it makes life so much better when you found the right fit for you. And it's a fun challenge, both as a user and a tool maker, let's say. But yeah, always the right tool for the right problem. I think that trying to fit a streaming tool into a batch process directly or a batch tool into a streaming process directly is just a losing game. So right tool for the right problem. And better yet, when you can combine, or when you can use one tool for multiple problems, actually, like it's built for that, I think that's really fantastic. So that's all I have in terms of content. But I'm happy to go back to any slide as we chat. Thank you so much.
Thank you. I can ask another question.
As many as you.
Is there a case where Upsolver is the wrong tool? Hi, Alex.
Yeah, of course. So one thing is that it is SQL only. So if you, sorry, I'm getting really cold. Just give me 1 second. Like starting to shake here. It's sitting next to my air vent.
That sounds nice. It's very warm in New York.
Oh, so yeah, so if you're wanting to do a lot of machine learning stuff, for example, because most ML libraries are Python first or Python dependent, then I think you would run into frustrations trying to use Upsolver for that. We used to support Python UDFs sort of, but it's just the level of abstraction and the tooling space that we are in, we're really going for, you have a bunch of SQL transformations that you run. It is clearly a pipeline rather than getting someone else to write that pipeline for you, or, like hacking it in some other way. Just write your SQL, we'll deal with the pipeline kind of thing. So yeah, there's definitely, I wouldn't recommend it for ML. Let's see. But I mean, because we handle both streaming and batch, like you can't, even if your workflow is streaming only, that's fine. If your workflow is batch only, that's fine. If you combine the two, that's fine as well. So in terms of that, there's like a good coverage.
Thanks.
I had a question. So a lot of your examples that you pulled from, it looked like, I guess maybe more from my perspective seems complex, like you're transforming live streams of data, maybe from like websites or active applications on the internet. Say you're, just starting out and you want to practice like making a predictive analysis model off your data, like maybe for my budget or something. What kind of tools could I use to do that?
Yeah, most use cases are not real time, right? Even today. Again, like going back to where I started, I think analytics and just like making sense of data is a really big portion of what we do day to day. You certainly could use a tool like Upsolver. So the thing is that like if whatever source you ingest from, fine. Like let's say your data exists in BigQuery or something, just bring it in, and you can see the data within Upsolver, you can interact with it, you can run queries in it. So it's not just you can create a job and then make that job, run pipelines, but you can also just interact with the data. So you could just do it all in Upsolver. It doesn't have to be complex. And then like if, so are you sort of, if you don't mind me asking, like, are you sort of starting to play with data? Is that the?
I think most of what I've been doing with data is modeling data, but you touched a lot on not only modeling the data, but using it to build predictions or, basically to help your customers out, which is ultimately the goal. So I guess I'm just wondering how I could do that with a personal project, and using maybe number sets that I have access to, which, maybe like my budget, or I could pull something off of, offline somewhere. But you say Upsolver is a good tool for that?
Yes. So the life hack here is most tools give you a free trial period, right? And for a personal project, usually that's enough. Like if you get 30 days, I mean, you have to plan it out ahead of time and sort of have an idea of what you want to do in that tool. But so that's what I would recommend. I mean, don't shy away from these enterprise tools just because they're not really for personal use, because they will let you do personal use just to get you hooked. So yeah, try I mean, I love Databricks, for instance, and I get nothing for saying that, right? I really enjoy using Databricks. I think they have a really good user experience, and just hop on there. It's notebooks. So if you use Jupyter at all, have you used Jupyter?
Yes, I'm familiar.
Yeah. Then it's the same experience almost within Databricks. It's just a notebook, and you can, but the difference is that instead of having a CSV in your local computer and saying, load pandas, load CSV, you can put the CSV in your Databricks, database, and then you can work with it in the notebook directly. So it's in the cloud, and you're sort of working with it. And that's the other thing, that like the trials will include a little bit of space in the company's cloud infrastructure, right? So you can get that cloud experience. You don't have to be limited to your local machine. But speaking of local machines, I mean, there's like DuckDB now, which I haven't played with myself. I don't know if Alex, you have, but it's basically it lets you do more intense database stuff just on your computer. You don't have to worry about the cloud. So the tools that that folks mention and are like you see everywhere, you can usually try them out and play with them yourselves.
Okay, cool. Thank you.
Absolutely. But yeah, I started with Jupyter and doing ML models off of scikit-learn, right? I think that's a great place to start. Data sets, public data sets. People get them from Kaggle. BigQuery has a bunch of data sets, and it's just I will, like, most of the tools that I learned, I did learn on the job, but if I were doing it all over again, I would use this advice that I know now, which is like you can start using those things before you have to on the job, but also they're not that hard to learn on the job. So yeah.
Cool. Any remaining questions? Also, I want to say thank you, Santona, for coming. And then for those who don't know who I am, I'm Alex. I'm generally the organizer of this meetup. I just had some random things that kind of took me away from the beginning today. But I'm very glad to meet all of you, and hopefully you guys will come to future instances of this meetup. And you had a really good time tonight because Santona's really awesome, and I caught the back half and it was pretty awesome. But yeah, any questions? And then 2, make sure to add Santona on LinkedIn if you haven't already, so that way you can follow what's going on at Upsolver. And actually, I have a question. What in the near term will Upsolver be introducing? Any new connectors for ingesting data or delivering data to anywhere in particular?
Are you looking for me to say iceberg? Because yes, iceberg for sure. Yeah, we're gonna support iceberg as a file structure. We have some cool stuff coming with DBT. So we're building DBT connectors. Nice. One of the things that from talking to folks that use DBT, it's really great for writing models and whatnot, but it struggles a little bit with incremental models. So models where the data is changing more frequently, and that's where that's our specialty. So Upsolver is going to make writing incremental models in DBT a lot easier. Oh, nice. Yeah, and then we are also doing so. Another thing that we realized through user research, which again is very fun, is that a lot of the pain point in data pipelines is actually data ingestion, especially like in an enterprise setting, right? Just getting your data to your warehouse and doing it in a way that you can trust your data. So we're we're launching a few features around additional observability and data quality checks at ingestion time. So as you're reading your data from Iceberg and it's landing in your Snowflake, we're gonna do strong ordering of the data. We're gonna do consistency. So like if you have two records coming, like two copies of the same record coming in a stream, then we're going to dedupe that for you in as it comes in real time, and so everything happens exactly once. Yeah, so there's some cool stuff coming there. And finally, that ingestion is also going to be supported in a wizard. So you're not even going to have to write a lot of SQL. You can just sort of say, oh, I want my data coming from source A, and I wanted to land in some in target B, and then you just say, like, whether you check boxes for, like, do you want to dedupe, do you want to mask some fields, whatever you want to do, you sort of specify all within a little wizard, and then your pipeline is created like magic.
That is super cool. Okay, so everyone who watches this after the fact on YouTube, that's pretty cool. So go back and check Upsolver and I forget, does Upsolver have a free trial? Or
yep. Mm-hmm.
Yep. Okay, so then go do the free trial. Go try it out. Go. Cool.
Oh, I wanted to ask, so like talking about these features that are in the pipeline, how many of those are you like overseeing as a product manager, and how long does it take? Like I'm curious about your job.
Yeah. No, that's a great question. So it's been a month and a half that we decided, since we decided to do that ingest, to focus on the ingestion component and make the ingest wizard, and it's going to launch next month. This month. We're in April. Yeah, that's really fast. And I mean, partly it's a startup, and we're agile and we like to move fast. So that's super exciting. and just seeing. So I've only worked at startups. I like to say, like, I have a background in particle physics, which was a 5,000 person collaboration. But aside from that, I've only worked at startups, and it's not always fast. Like, there's definitely slow and places that are slower than others. But yeah, this has been really cool to see just, how quickly things are turning around. I got to be very involved in the ingest product, but I mean, I didn't own the whole thing. I was working with another product manager on the team, and we sort of like just had working sessions where we came up. And again, this is what helps. This is what helped me at an Upsolver to go fast, is we just block out 3-4 hours. I mean, it's virtual, right? Where everyone's distributed. It's really hard to get that sort of in-office experience, but would do like pair programming or pair, designing for 3 hours, and just talk through the flow, the user flow that we wanted, what concerns we had. And, at the end of the day would have, a Figma or, a Google Slide suite that just had the whole thing done. And then we iterated on that a couple of times, and then we were like, here's the design, here's what we want to build. So yeah, it's been a lot of fun for me, learning a lot of product stuff for sure, have great guidance at Upsolver. So yeah. It depends on the size of the product and the feature, how long it's going to take, obviously.
Yeah, I was going to ask about that too. Like, in your iterations, do the engineers or whoever's working on the product on the technical side, do they have to like stop things? How do they know to keep going while you're iterating on the original design?
Yeah, it's definitely an iterative process, and I've done this differently at different places. Typically it's product, if you're interested in product, typically product managers will be embedded into engineering feature engineering teams or product engineering teams, right? So you'll once you've written the product requirements document, and you create sort of the task set. Alex, is this okay? Are we going over too much or anything? Yeah.
No, I mean, up to you. When you say you're done, I will close the thing, and then I will